Microcontroller, very good. Good morning. So today we have the breakdown for the Wi-Fi. So everything is messed up over here and here, so I cannot connect everything. Okay, let's start. So today is the second last day for the class before I complete the whole chapter that I have to do. So we are going to learn another 2 more motors, but today only 1 motor. And the last class will be on Thursday, will be the last motor, and we have to do some of the practical first. Alright, so today maybe need only for the final Proteus simulation should be enough. Okay, alright, we have to do this. Now let's talk about the motor. So far you have learned a type of motor which is called DC motor. Remember that, DC motor? So in this microcontroller class, only 3 motors that you will need to learn. The first one is DC motor. The second one, we are going to learn servo motor. And the final motor will be called stepper motor. So these 3 motors are different. So you need to compare each of them and use accordingly to your project. If you are using motor, you have to use a correct one or suitable types of motor that you want to use. Okay, this is for servo motor today. Servo motor is very simple, but the coding will be a bit confusing. Alright? So what is servo motor? If you have the board on your table, servo motor is located on top right. The third one, which having the flipper, that one. So this is a type of servo motor. The one that we are using on the board is this one. So servo is different. It can only rotate accordingly to the degree. 0, 90, 180. Alright, only these types of movement. Compared to the DC motor is continuously spinning, rotating. Right? Continuously. So the one that you are going to learn today is the one that only move from 0 to 90, 90 to 180. Only 3 movement. That's why this type of servo motor normally used in the robot. Normally put at the what they call it, at the hand, at the legs, ankle, something like that. It's not on the movement. It's related to the degree of freedom. Like this. Here is an example. You can see that normally the servo motor is located over here, over here. This one is over here, is to move up that particular degree. So the normal one for the movement, like for the motor, you are going to use DC motor for the movement of the robot. Normally it's like that. For the servo, it's only a few degree of freedom. That's all, Alright, this is the example. So how to control that? To control a servo motor, you still require to use PWM. The only exception thing is you are not going to use CCP pins. CCP pins cannot support this type of PWM. I repeat, your CCP pins on CP1 and CP2 on the hood, CP1 and CP2, CCP1 and CP2 at port C is normally used for the DC control for the PWM. But this PWM cannot support this type of PWM. So you have to create your own PWM to control it. Okay, so very simple. If you have this type of PWM, 1 millisecond for the PWM, and the whole period must be 20 milliseconds. The whole period must be 20 milliseconds. For the servo motor, you require to have the total period from here to here is 20 milliseconds only, which is the CCP pins cannot support that particular period. So the first one, if this one PWM is 1 millisecond and the rest is 19 milliseconds down here, and keep on repeating, your servo motor will be controlled to 0 degree. Servo motor will move to 0 degree. Alright? So the next one, if you are controlling the PWM to up to 1.5 millisecond and the rest 18.5 is down state, you are going to control your servo motor to 90 degree of movement. And the last one, for the 180 degree, the PWM must be around 2 milliseconds and the rest 18 milliseconds should be down state, and this is going to control up to 180 degree. So it's very simple. To move like this, you have to give this PWM. To move like this, you have to give this PWM, and to move like this, you have to give to this PWM. The only difference normally with DC motor, for your servo motor, there are only 3 connections. If you can see on the board, your servo motor, for example, here is your servo motor, there will be only 3 connections available. One is the positive, which is the 5 volt. Next one is negative, which is the ground. And the last pin, they call it signal pin. Signal pin must be connected to the PWM. So this PWM will be fed to the servo motor, and the servo motor will behave accordingly to what that you want. If you give this signal, it will rotate to up to 90 degree. If you give to this signal, it will rotate to up 180 degree. Okay, let's see for example first. I see you the waveform. I give you the waveform before you try. So here is the Proteus. For the simulation purposes, we have 3 servo motor, all connected to different pin on RA. RA, you can look back at the book. RA for pin number 3, number 4, I start from 2, 3 and 4. Okay. RA0, RA1, RA2. You can look at the book, the picture over there. The label is either R/AN, which means that that particular port A can be used either as digital or analog input. AN means analog, R means digital. So you can choose. When you want to do the setting for port A, you have to choose whether you want to use as what? As output or as input. For the input, it can be either digital or analog. For the output, will be only digital. You cannot generate analog output. Okay, so look at that one, right? So now, here is the one that I set up as digital output. So you can see later, I will show you the waveform. So this is already run. So let's look at the position by default. I start this one first. So this is all the position before I give the PWM. There are 3 positions here, all at the same position. So I run this one first. Look at the positions of the servo motor. One is moving the other direction, one is keep on the center, and the other one is moving on the other direction. So I stop again, I run it for you again. Okay, let's do it. This is the one. So I run this one. Right, you can see that one. So let's look at the PWM here from your oscilloscope. This is the PWM on your oscilloscope. So this is for the pin A, 0, pin 1 and pin 2. Look carefully. Right, so the A is going to be R0. So A is this one, second one is this one, and third one is this one. So I generate the PWM accordingly to the what the slide says to control it correctly. Okay, how to generate the one? You have to learn timer 0 today. Timer 0 is a bit confusing, so I think to teach you that one. Okay, now this is the one. Look at this. So how I calculate this one? You can see that the first PWM, you can basically use this one to look at. This is the first stop, and then this is the value of this one. Let's try it. I stop here. Okay, and I have this one here. Okay, that's right. Okay, so that is the line. Okay, this is 0 seconds. You can see that that is the 0 second, the first period going up. And the whole PWM, the value is, you can use the one shot over here and click over here. That is what? That is 1 millisecond. Correct? And then the whole period, I have to look at it. What is the what should be 20 milliseconds. So the whole here up to here should be 20 milliseconds. That is a bit error, I think measurement error. For me, I cannot use the cursor correctly. So that one is 20 milliseconds. Right, you can see that this is 20 milliseconds. So this is one millisecond only. So the whole total period is 20 milliseconds. This is 19 milliseconds. Right, let's look at the other PWM. So this one is at 0. This one is at 1. Around 1.4, 1.5, something like that. My cursor is not really good that one. So you can look at one is around 1.4, and this one should be around 1.7 if I remember. 1.9, sorry. 1.8. Okay, this is how you generate the PWM accordingly. But we are going to learn timer 1. I give you the code first, you run it first, look at the result first. And accordingly to this one, right, for 1 millisecond is going to be 0 degree, 1.5 is going to be 90 degree, 2 milliseconds around that one is around 180 degree. So let's run that one again. So this is anti-clockwise, counterclockwise, this is clockwise. So run the procedures. Let's try this one first. Okay, so you have to write this one first. Open up your Proteus and run this one first. Okay, run this one and run the Proteus. Look at the result first. I give you time for around 50 minutes.